Today I'm going to show you how the dot product can be used to create some interesting functionality in relation to the player and other enemies. So in this example here we can see that the enemy is in front of the player. So if we were to go up behind them and do an attack while we're in range, it would do a critical attack and take off a high amount of health, whereas if we were beside the enemy and to do the same attack, it would only take off a small little bit of health. So we can create some interesting functionality like that. Also, we'll notice if we change the player's direction till he's facing away from the enemy will start sneaking up on the player. But then when you look back, he will stop. So if I was to pass him out here, and now he's behind us, he'll start sneaking up on us until we return around and face him again. So I'm going to show you how to create that functionality today, using pretty much just the dot product. So let's start by just doing a quick bit of setup. So let's just add a plane, set that to 0, 0, 0. Let's move this light completely out of the way, and let's add a capsule that is going to be the player. Let's just move him back a bit, and let's add a cylinder underneath that so we can see which way he's facing. Okay, so it's going to add a cylinder. I'm going to scale it down. I'm going to rotate it 90 degrees and just pull it out in front a little bit just so we can see which way this player is facing. Just make sure that that's in the forward direction, so following the blue arrow on the player, the forward direction of the player. Let's create another capsule, which is going to be the enemy. Okay, we'll just move him up a bit. Let's give both of these a height of 1. Okay, so set the Y value to 1. Whoops, 1 and 1. Yeah, that's correct. And then let's just create some materials just so we can distinguish these. So let's just create one material here. We'll call it red, and that can be for the enemy. Just make this red. Drag that onto the enemy. Okay, let's rename these so we know which is which. This is player. This is the enemy. And let's just create a material for the ground so it's we can see the player a little clearer. So let's just call this gray, and just make this a bit of a gray color, and then drag it on to the ground. Okay, so this is pretty much the setup done. So let's just have a look at what exactly we'll be using with regard to the dot product. Okay, so what is the dot product? The dot product is just a relationship between two vectors. Okay, so if we have a vector here that we will call A, and we have a vector here called B, getting the dot product of these two vectors is going to let us determine how similar they are to each other. So basically, how similar is B to A and how similar is A to B. At least that's what we're going to be using it for in this tutorial. Okay, it is a little bit more in depth than that, but that's pretty much all we're going to be using it for. We want to find out how similar is one of these vectors to the other. Okay, so what do we mean by how similar are they? We basically just want to find out, are they going in the same direction or not? Okay, so when we get the dot product of two vectors, we're going to end up in one of three scenarios. So either they're both going to be going in the same direction, like this, they're going to be going in different directions, like this, or they're going to be perpendicular to each other. So if you just imagine that was a straight line, like this. Okay, so when we get the dot product of two vectors, if they're both going in the same direction like this, we're going to get a value of 1. If they're going in opposite directions, we're going to get a value of -1. And if they are perpendicular to each other like this, we're going to get a value of 0. Okay, so a few other things we kind of need to know about vectors moving forward is just this here. So if we take that we have a vector here, and this is vector A, the direction of this vector is pretty much infinite. Okay, so it's going in this direction, but you know, it could be going off for miles in this direction. Okay, but the vector also has a length. Okay, so the length is this part here, is the magnitude of the vector. That's this part. Okay, how long it is. So for example, this could be 5 units in length. Okay, and it is pointed in a certain direction. Okay, so if you think of, you stand outside and you point a torch north, the torch might only shine actually 5 meters, but it's, you know, it's still pointing, you know, indefinitely north. Okay, so another thing that we need to know is that we can normalize a vector. So to normalize a vector, we just give it a length well, essentially we give it a length of 1, okay? So normalizing a vector lets us get a unit vector, which is a vector in a given direction with a length of 1. So the unit, if we were to normalize this vector here, okay, so this vector that we have here, this vector that has a length of 5, if we normalize this, we would end up with this vector here, okay? So it's still going in the same direction, it just has a length of 1. And why is that important? Well, that's going to be important for when we're calculating the dot product. Now, we're not going to be using a lot of maths ourselves, really, in this work, because Unity is going to have built-in functions to do this. But this is just to understand what's happening behind the scenes and how this is being done. So if we, when we calculate the unit vector like this and get a length of 1 for the two vectors that we're going to be interested in, it's just going to make the we're going to get more rounded numbers. We're going to get nicer looking numbers for our dot product that will fall in line with what the kind of numbers we're looking for over here. Okay, so let me just show you what these two vectors. Okay, so I'm saying here that we're going to be comparing two vectors, but what two vectors? What two vectors are we going to be comparing? So if we imagine that we have a player here. Okay, so this is a top-down view. That's his head, and these are his arms. Okay, so think of a top-down game. This is the player and he's looking in this direction, okay? This is the first vector that we're going to be concerned with. This is the first vector here. So if you look at these two up here, imagine this is the first one. This is vector A, which is the way the player is looking. That's the first vector. I'll just do P here for player, okay? And then imagine we have an enemy. We have the enemy here, and he's looking, well, actually it doesn't matter what direction he's looking in, but this is our enemy here. The second vector we're concerned with is the direction from the player to the enemy. So let me just move him back a small bit. Let me just move the enemy over this way a small bit. Okay? The second vector is this vector here, from the player to the enemy. And let's just call that B. So these are the two vectors that we're going to be comparing. So we can end up in this scenario here where the player, the enemy is beside the player. So let me just scale this down a small bit. Okay, this is the first scenario. We can also end up in the scenario where we have the players here. Let's draw them again. So the player is here, looking in this direction, and the enemy is here. Let me just put P for player again, E for enemy. Okay, so the enemy is in front of the player. So that means that this second vector here, this is A. This is the direction in which the player is looking, but the second vector is pretty much is pointing in the same direction, pointing towards the player. Okay, and then the final example is when we have the enemy here. It's E for enemy, and the player is in front. So the player is looking in this direction, and the enemy is here. And the direction, the second vector to the enemy is behind like this. Okay, so we have A here, and we have B here. So I just scroll out, and we can compare these up here. Okay, so we can have a scenario like this where our first vector and our second vector are pointing in the same direction. That's like this one here, where the enemy is in front of the player. We can have a scenario where the enemy is behind the player, which will give us -1. So we'd have the player here, and the enemy is behind, meaning the two vectors we're concerned with are pointing in opposite directions. Or we can have a scenario like this here, where the player is looking in a given direction, and the second vector is out to the side, so that the enemy is beside the player. Okay, so when we take these two vectors in any of these two scenarios like this, and we get the dot product of these two vectors, we're going to end up with a value of either 1, -1, or 0, and that's going to let us determine if the enemy is beside, in front of, or behind the player. So it's worth knowing as well that when we say pointing in the same direction, it doesn't have to be absolutely exact. So the two vectors don't need to be absolutely like this, okay, like absolutely perfect. It can be a little bit like this. Like they can be a bit off. All of these would result in all any of these would be a value of 1. Okay, so let me just do that again. If we take A here, if I make this green, okay, so the way the player is looking here is green, and the vector to the enemy is red. If we had this scenario, where the player is looking this way and the vector to the enemy was any of these would all result in this scenario here, where we will get this 0 value. It doesn't have to be absolutely exact, and we are going to be doing a small little bit of rounding as well, so that'll help with that as well. So let's just have a look at how this is actually being done. Even though we're not going to really be doing any of this maths ourselves, it's probably worth just knowing how it's actually done behind the scenes. So let's take this example here. Let me just clear this out, okay? Let's take this scenario where the player is here and the enemy is here, okay? So the player is looking in this direction. The enemy, the vector to the enemy is in this direction. We don't care how far the player is looking in this direction. We don't care if he's only looking this far, if he's looking this far, if he's looking this far. We don't care if he's looking this far. We don't care how far he's. All we need to know is he's looking in this direction. It's the same for the vector to the enemy. We don't care how far in this direction it is. All we care is that it is in this direction. So in this scenario, what we would do is we would normalize these two vectors to make them of length 1. Okay, so to end up looking something like this. If we were to normalize the player's one, it would look something like this. The vector would be around that long, we'll say there, and the same for if we were to do it with the player. It would be somewhere around this length, okay? So both of these vectors will be of length 1, and we can then use the dot product of these two vectors, these shortened vectors, we'll say, to bring back a value that would fall into the range of one of these three, okay, either 1, -1, or 0, okay? So let's have a look at what that would actually look like, okay? So if we, let's create a vector at point, let's do point 4, 3, okay? So this is 4, 3. Badly drawn, but that's it. And let's create another one at 5, 2, okay? This is 5, the X, 2 on the Y, okay? Let's call this A, let's call this B. So let's assume the player is standing here. Let's say the player is looking in this direction. And let's say the vector to the enemy is in this direction. Okay? So to determine whether the player is in front, to determine whether the enemy is in front of the player, to the side of the player, or behind the player, we can use the dot product of the normalized vectors. Okay, so remember, the first thing we need to do is actually normalize these two vectors to get them a length of 1. Okay, so to do that, let's do that here. Let's take the first one. Let's take A. So this is vector A here. Okay, everything we're going to do here is for vector A. So vector A is 4, 3. Okay, and to normalize the vector, the first thing we need to do is get the length of that vector. Okay, so we need to get a length. If actually no, alright, so just to do that, what we need to do is this: we need to get the square root. So to say square root of that vector. So the way we do that is we take the x component, which is 4. Okay, so we take the x component here, which is 4, and we square that, and we add that to the y component squared as well. Okay, so that's 3. So that will leave us with 4 by 4 is 16. Sorry, I should say this is the square root of this would give us the square root of 16 plus 9. Okay, so we're left with getting the square root of 25, which in this case is 5. Okay, so that means the length of this vector is 5. So we can write that in now. So the length of this vector here is 5. Okay, again, we're not going to actually be doing any of this maths in code. This is just showing us how it's done behind the scenes. So now we need to get the length of this vector. Okay, we need to get the magnitude of b. Okay, so let's write that in here. So b so vector b is equal to 5 2. Okay, so we do the exact same as we just did. So the square root, so we get the square root of this. So the square root of the x component, which is 5 times 5 plus 2 times 2. Okay, that leaves us with the square root of 25 plus 4. So that leaves us with the square root of 29. Okay, so which is a bit of an awkward number, but it doesn't really matter. Okay, so now we know that the length of this is the square root of 29, so we can write that in as well. So this is the square root of 29. Okay, so what we need to do now is, let's go back to A, and now we have this value 5. So what we need to do is to take the original vector, which is 4 3, and we need to divide each of those components by this value, by its magnitude. Okay, so let me just drag this over. So now we have vector A is 4 3. So let's take 4, the x component, divided by 5. Okay, and the y component is now going to become 3 divided by 5. And what we're going to end up with then is 0.8, 0.6. Okay, so now the normal vector, so if you look at this little blue one back here, the vector of length, of the unit length vector is 0.8 for the x and 0.6 for the y. So what I could write that in at here is, if I make this, I'm running out of colors, so if I make this light blue, we would have in this direction for A, we would have this vector here. Okay, that is what this is here. This here, 0.8, 0.6, is this unit vector here. So it's going in the same direction as this, as 4 3. It's going in the exact same direction as this one, but it's of, this is the unit length. Okay, so now we need to get the same one for this b vector here. So let's just go over here, drag this in, it's back to black. So what we end up with here is the square root of 29 is the magnitude, it's the length of this vector. So we divide both the x and the y by that. So we end up with 5 divided by the square root of 29, and the y value then is 2 divided by, where am I, SQR, the square root of 29. And what that ends up leaving us with is a bit of an awkward number. Okay, so it's 0.92847669088 for the x, and the y, just make sure there's enough space, is going to be 0.37139667635. Okay, which is pretty awkward, but that's what that unit vector is here. So if I was to color that one in, let's say brown, that's what this would be here. Okay, this one, sorry, so that's really bad, but if you were to zoom in, that's what it would look like. It's just a small arrow in the same direction here as this, but with the length, it's the unit length of 1. Okay, so that means now these are now our two unit vectors, these here. Okay, this is the one for the A, this is the one for the B. So what we need to do then is to actually calculate the dot product of these two vectors. Okay, so the formula for the dot product is A times is the x component of the first vector multiplied by the x component of the second, plus the y component of the first vector times the y component of the second. Okay, so that would be 0.8 times this big long number, so that would be 0.8 times 0.9288 0.84766988 plus the y component of the first one, 0.6 times the y component of the second, which is 0.37139667635. Okay, what that ends up giving us is a number that, well, it ends up giving us a really long number that is almost 1. Okay, it's pretty much just about 1. It actually ends up, I think, being 0.9 something. You can work it out yourselves if you want, but that's pretty much what it's going to be. It's just going to be 1. And remember, I was saying it doesn't have to be absolutely exact, because we are going to do some rounding. We're going to be rounding to the nearest whole number. So this gives us a value of 1, which is going to tell us that the enemy is in front of the player, because both of these two lines are pretty much pointing in the same direction. So if we were to look down here in this example here, you can see where the two lines are pointing in the same direction, that the enemy is in front of the player. So again, we're not going to actually be doing any of that maths really. It's going to be kind of handled for us, but that's what it's doing behind the scenes. So I'm going to go back into Unity now and actually start doing some of this. Okay, so now that we have a bit of an understanding of how the dot product works and why we're going to be using it, let's create a script that is going to calculate that in Unity. Okay, so let's just create a script called let's call it dot product, and we'll just add that to the player. Okay, oh, is that working? Just add that to the player, and just open that in Visual Studio. Okay, so the first thing we need to do is, create a reference to the enemy. Okay, so let's create a public transform, call that enemy, and let's also create a float for the dot product. Dot product. Okay, so the first vector that we're interested in is the direction in which the player is facing. Okay, so let's draw a line that shows us that. So let's do debug dot we'll actually do draw array. We'll draw array from the player's position. So remember, this script is on the player, and we want this to point out in the forward direction that the player is facing, and we'll just give it a length of 20. Now again, this doesn't matter. We can give this a length of 200 or 2000 or whatever you want. It doesn't matter. The length doesn't matter. We'll just make it a little bit long so we can kind of clearly see the direction that the player is facing. And let's make this blue. Okay, so this is the first vector that we're concerned with. Okay, so now what we need is this second vector, this vector here, B, the one that points from the player to the enemy. So that's what we're going to do next. So let's create a vector here that's going to store that, and let's just call this let's call it vector to enemy. Okay, and this is going to be the enemy's position minus the player's position. Okay, so the way to read this is the second part of this is actually where you start the line, start the vector, and this is where you end it. Okay, so we're saying draw this from the player to the enemy. Okay, and what we want to do then is we want to draw that out. Okay, so we want to do a debug.draw array, and we want this to start at the player's position, and we want this to go in the direction of the vector to the enemy. And let's make this red so it's easier to see, and let's give this we're just going to multiply this by 20 as well, just to give it a bit of length, just so we can see clearly see where it is. Let's have a look at that first before we do anything else. Let's go back into Unity, and we just wait for this to compile down here. And now we need to drag the enemy onto this field here. Okay, so let's drag the enemy onto that, and let's just press play. And you can see there that we have a line being drawn from the player to the enemy, and we see the player is facing in this direction, and that is that's the blue ray there, the direction that the player is facing. Okay, so now let's actually go calculate the dot product. So again, to calculate the dot product, we need to pass in the two vectors. Okay, we need to pass in two vectors. So what we're going to do is we are going to store the dot product in this dot product variable. So We don't need to write the maths for this. There's a function in Unity called vector3 dot dot, and that's going to let us pass in two vectors, and it's going to return the dot product of those. Okay, so we know the first vector is the forward vector of the player. Okay, we can just type dot normalized to get the normalized version of that, which is exactly what we're doing back here, where we're calculating these. So it's a vector in this direction. So it's in the direction that the player is looking, but of a unit length, okay? And we're going to do the same for the second. So the second one we want to pass in is the vector to the enemy. We're just going to normalize that as well, okay? And that is going to return the dot product value. So let's just save that here, and then let's debug this out, okay? Let's go debug.log dot product, okay? So in the console now, we should see the dot product of these two vectors being output. Press play, and we'll just change the console. Okay, so here we see the dot product being printed. So this is a pretty long decimal number because we're not doing any rounding yet. Okay, so if you just take one look back at this, remember if the two vectors are pointing in pretty much the same direction, we're going to get a value of 1. If they're completely opposite, we're going to get -1, and if they're perpendicular to each other, we're going to get 0. So if we go in here, we can see that these are pretty much the same, so they're almost at a value of 1. Okay, if I was to rotate the player to about 90 degrees, give or take, we see that we almost have a value of 0. Okay, 0.05, almost 0. And if I was to make the player turn completely around, you see that we have a value of pretty much -1. Okay, and that's because I just haven't done this absolutely exact. Okay, so the next thing we're going to do is go back in and actually round that number. Okay, so what we're going to do is we're going to wrap this where we get the dot product here. We're going to wrap this in a function called mathf.round, and all that's going to do is actually round this number to the nearest integer. Okay, so if we just save that and go back in, and now if we run this, we're seeing that we're getting a value of 1. Okay, so we're saying this this was around 0.9 before, but now we're getting a value of 1. And you see when I turn that there, this is the player. The enemy is still pretty much in front of the player. Okay, so this isn't changing until I go to make this at least perpendicular, at least 90 degrees. And now we can see that that's changed to 0 because the player, the enemy is at give or take 90 degrees to the player. And then when I turn fully around, you can see that's changing to -1, indicating that the enemy is behind the player. Okay, so let's go back into Visual Studio now and actually write some code to do some different things depending on where the enemy is in relation to the player. Okay, so at this point here, we know the dot product. Okay, so let's just create an if statement here, and let's just say if the dot product is equal to 0. At this point, we know the enemy is beside the player, and then we can go else if the dot product is equal to 1. We know that the enemy is in front of the player, and then the final else check is if the dot product is equal to -1, we know that the enemy is behind the player. Okay, so what we're going to do now is if the enemy is behind the player, okay, that obviously means that the player is facing the opposite direction. So we're going to make the enemy sneak up on the player. Okay, so to do that, we need to create a script on the enemy. So let's select the enemy, and let's just create a script called move enemy. Okay, let's just open that. Okay, so let's give this enemy a speed because we want him to move. He's going to need a speed, and let's just set that to something really slow because we want the enemy to sneak up on the player. Let's also give the enemy a reference to the player. Okay, and let's also create a bool. Okay, let's create a public bool called player looking away, and let's just set that to false. Okay, and all we're going to be doing here is a check So let's store the direction to the player first of all. Okay, so we want this enemy to know how to walk towards the player. So to do that, we're going to need the direction to the player. And all that's going to be is the player's position minus the enemy's position. Okay, this is going to give us the direction to the player. And if the player is looking away, all we're going to do is move the enemy, so we can use transform.translate. And you can see here that this moves the transform in a direction and a distance. Okay, so what we're going to say is move this enemy in the direction of the player at whatever speed we've defined, and we want to do this every update. So we want to do this time delta. Sorry, we want to do this in seconds. Okay, so we want to do this quite slowly. Basically, is what we're doing. Okay. This is only going to happen if the player looking away value is set to true. Okay, remember this is set to false by default. So if we go back into our .product script, what we want to do in here is we want to give the player a reference to this enemy script, so we can update that player looking away value. Okay, so let's just create a reference to that script. So let's create move enemy, and let's just call this move enemy. Okay, and in the start function, let's just set that. So let's say move enemy equals, and we already have a reference to the player, so we can just get component move enemy. So then in here, when we know that the enemy is behind the player, we can just check to see if this player looking away value has been set to true. Okay, because that's what we want to set it to true. So let's set it first. Let's just say move enemy dot player looking away is equal to true. Okay, but then we're just going to put a little check around that because we don't want to keep setting it to true if it's already true. So we'll just say if move enemy dot player looking away is not equal to true, and if it's not already set to true, well then we'll set it to true. Okay. And this just prevents us setting it every single time. So now if we go back in and we run that, well actually no, before we run it we need to fill in the components. So we need to give the enemy reference to the player, so just drag the player across here onto this. And let's just make sure there's nothing missing there, there's nothing missing on that. So let's just run this. Okay, and nothing's going to happen because the player is in front. The enemy is in front of the player, but if we select the player now and press E and we rotate the enemy until rotate the player until the enemy is behind, you see that he'll start moving towards the player. But he's not going to stop because we don't tell him to stop anywhere. Okay, so let's do that next. So if we go back in, we know here that the enemy is in front of the player when the .product is equal to 1. Okay, so let's just make the enemy stop moving towards the player in here. So we can just do the exact same check. We can actually even just copy this. We can just do the exact same check here. We can paste this in. We can just say, at this point, we are facing the enemy. The enemy is in front of us. So if he has not already stopped moving, if the player looking away is not false, set it to false. Okay? Because at this point the player isn't looking away. Player looking away is false because we're looking directly at the enemy because he's in front of the player. So we're just going to tell him to stop. Okay, so if we just save that, go back into Unity and now run, we see that the enemy isn't moving. If we turn away, he'll start moving, and then when we turn back and face him, he'll stop. Move, and he'll stop. Okay, so if we go back in here now, we can leave it at the side. We could stop him as well when he's in the side, but there's probably no need to do that. What we actually want to do, actually no, what I'm going to do now is we're going to put the script on the player to be able to move the player, because it's getting a little bit tedious constantly moving him like this. So let's just create a script that will let us do that. So just create a new script called move player, and just open that in Visual Studio. And there's a few things we're going to put in here. So the purpose of this tutorial is to learn how the .product is being used to determine the position of an enemy in relation to the player. So I'm just going to paste in this script here, okay? I'll zoom out so you can see what it is, but I'm not going to go through this script in any kind of detail. Basically all it's doing is when we press either the up arrow or the down arrow, we're just moving the player forward by a certain speed. That's all we're doing. We're just moving him in a forward and backward direction, and when we press the right or left arrows, we're just rotating him on the spot by whatever the rotation speed is up here. That's all we're doing. Okay, so we can just copy that in, and then we can move on. So if we go back into Unity, then just make sure that that script is added to the player. So just select the player and just drag this move player script on, and if you just press play, using the arrows we can then rotate the player and move him forward and back. Okay, so if I turn my back on the enemy, he'll still continue to go towards us. If you look, he'll still stop, and then if I walk past him to make him end up behind us, you'll see that he'll start walking towards us again until we turn around and face him again. Okay, so so this is pretty much everything done with regard to the dot product, but what we need to do now is be able to actually attack that enemy. So if we go back into let's go back into Unity, or back into Visual Studio. What we want to do now is create a function that will let us attack the enemy. So let's just create a function called check for attack. Okay, and let's also move all of this. Let's move all of this into a function called calculate dot product, and then let's call that in the update. So this is pretty much doing the exact same thing. Nothing's changed. We're just going to keep the functionality that we're about to write separate from this, and then let's call check for attack directly after that. Okay, so the attack code that we're going to write could be done in here. You definitely could write it in here in this section. The only reason we're not going to do it is to keep it a little bit neater and to not have everything in one function cluttering up the place. But it could theoretically be done in there. So, well, before we do the attack, actually, let's set up the enemy to actually be able to get attacked. Okay, so if you just select the enemy, what we want to do is we want to add a canvas to him. So if we add the text, let's add some text, and that will automatically add the canvas. So this is added a canvas under the enemy. Actually it hasn't, so let's just drag that under the enemy. So now let's change this canvas to not be in screen space. So let's click this and change this to world space. Okay, and let's select the text, zoom out, and let's scale that down. And let's just scale and position it where it's slightly over the enemy's head. Okay, so we can focus in on this. This doesn't need to be exact either. It doesn't need to be exact by any means. So to scale it down a bit further, bring it across. That looks pretty much okay there. Okay, so let's just center that. So let's center it, move it across again over the enemy, and let's just change the color to be white, a little bit easier to see. And let's change the size of that font to be about 25. Okay, and that'll do. So let's set this to 100 because this is going to be the enemy's health. So what we want to do is go back into this move enemy script, and we want to create a public reference to that text that we've just changed to 100. So to do that, what we need to do is we need to include using Unity engine.ui, and then we can type in public text, and we'll just call this health for the health of the player, for the health of the enemy. So now we need to create a function that will actually allow the enemy to take damage. So let's just call this take damage, and let's make this take in a float. Okay, so this is going to take in a value for how much damage we're meant to do to this enemy. Okay, so I'm just going to create another float here, just called d for damage, and that's just going to multiply whatever value was passed in by -1. Okay, so basically, if we call this function, if the player calls this and tells the enemy to take 50 damage, all we're going to do here is change that to end up being -50, so we can take this away from our health. So remember that the health starts off at 100, and what we're going to do in this function is take in a value and then take that away from this. Okay, so what I'm going to do as well is just create another variable called h for health, and what we're going to do is we are going to take whatever value is stored in here. So remember, this is going to be 100 starting off. The health is going to be 100, but this is a text value. It's not a number. So we're just going to change that to a number here. So what we can do is we can do system.convert .toInt32, and we're just going to pass in health.text. And all that's going to do is, if we go back to Unity and we select the select this text component, you can see that this is a number in a text field. So we have, this is going to be our health value, but we have it as a text value here. All we're doing is taking that text value here and changing it to a number. Okay, that's all we're doing there. And then simply what we're going to do is we are going to let h here, so let the new health, we're storing the health here temporarily, we're going to let that equal to the current health plus the damage. Okay, so what that's going to do is we're going to imagine we take in 50 damage when this is called. We are now going to change this to be minus 50 here. Okay, so we have minus 50. We have 100 stored here. And now what we're saying is we have 100 stored, but that's now going to be equal to whatever the current health, which is 100, minus this 50 is. And that's going to end up being 50. So the new health here in this scenario ends up being 50. And then what we're going to do is we're simply going to write that back to the text field that we have. So we're just going to let that, we're going to end up changing this number. Remember, we change it into a number here. We're going to change it back to a string and store that back in the health.text field then. Okay, so the new health will now appear over the enemy's head. So now we can go back in to the dot product and actually make that happen. Okay, so when we check for attack, when we do our check for attack here, there's a couple of things that we're going to need to know. We need to know if we're in range of the enemy to do the attack. We're going to need to obviously know the direction, because we're going to do a different strength attack depending on whether we're behind the enemy or beside the enemy. And we're also going to need then just a button, I don't know, space bar maybe, to actually do the attack. So the direction to the enemy, let's start off with that. Okay, so we're going to need to know a direction to the enemy. We're going to end up needing to know, are we in range to do the attack, and then we're just going to need to press a button to attack. Okay, so that's the three parts of this function. So we start off with the direction to the enemy. Well, we already have the direction to the enemy because we got it up here in this vector to enemy variable, but we can't access that here because that's not in scope. We see that we define that here. We define that within this function, so we wouldn't be able to access it. If I try type vector to enemy down here, nothing comes up because we can't access that. It's out of scope. Okay, so what we're just going to do is let's just copy this vector to enemy and let's just put that up here. Okay, and now we can get rid of this here where we declare it. So that's not going to change anything here, but it's just going to let us access it down here. So now we can go vector to enemy and we have that value. Okay, so why do we actually need that direction to the enemy here? Well, there's two ways that we can calculate whether we're in range. Okay, so we could do this. We could do a check like this where we go vector3 distance. If the distance from the player's position to the enemy's position is less than whatever the range is. Let's say the range is 2.0. We'll define that in a minute. Oops. Well, then we can attack. Okay, we could do it like that. But another way that we can do this that's a little bit more efficient and is the way that is recommended in the Unity documentation is to do it like this, is to get the direction to the enemy. Okay, so we already have that. That's the vector to enemy vector, and get the square magnitude of that and then compare the square magnitude to the range squared. Okay, so what that means is let's let's create a value here for the range. Let's create this first, make it a little bit clearer. So let's say we have a float called in range, and that is 2 units. Okay, so we're only going to attack the enemy if we're within 2 units of them. So in this scenario here, we would check the distance between the player and the enemy, and if it's less than 2 units, well, then we can attack. But the way it's recommended to do it is like this. We have the vector to enemy vector. So what we can do is we can create the vector to enemy squared. Okay, and that's just going to be the vector to enemy, and we get the square magnitude of that. And then what we can do is compare the square magnitude to the range squared. So then we would do a check where we go if the vector to enemy square magnitude is less than or equal to in range squared, which is just in range times in range, but then we'll do the attack. And this is essentially the absolute exact same as doing this, except this is the way that is recommended that we do it, because it's computationally quicker. So I'm just going to get rid of this here, and we're just going to do it the way that's recommended. So in here, what I'm going to do is I'm just going to debug.log out to say in range. Okay, so because we're calling this every update, this has been checked every update up here. Checking for attack. So at the moment, if we are in range of the enemy, this is going to print out. So let's just check that right now. Okay, so let's clear this. So when I walk towards the enemy, when we get in range of 2 units, you can see this is printing out, and if we move back, that stops printing out. Okay, so we move in, it starts printing, and we're out of range, it stops. Okay, so now let's actually handle doing the attack. So if we're in range, what we want to do is we want to check now and see what the dot product is. So what we're going to do is we're going to create a switch, and this is going to take in the dot product. And depending on which, whether the dot product is currently at 0, 1, or -1, which is going to mean, you know, we're either beside the player, beside the enemy, in front of him, or he's behind us, we're going to do a different attack. So you're going to see here that we can't actually pass the dot product into this switch statement. And that's because the dot product is currently a float. Okay, so we declared it as a float up here. And we can't pass a float into a switch. Basically, we need that to be an integer. So we're already we've already rounded it. So we're just going to do it again here quickly. We're just going to round the number. Okay. So what I'm going to do is create an int called dot, and we're just going to round the dot product. So we're just going to use the mathf dot round to int, and we're just going to pass in the dot product. And then instead of passing in the dot product here, we're just going to pass in dot, which is going to be the integer value, which means we can now do the switch statement. Okay, so now different cases we're going to have is the dot product is either going to be 0, it's either going to be 1, or it's going to be -1. Okay, so these are the 3 scenarios. So again, this means enemy is beside us, this means enemy is in front, and this means enemy is behind. Okay, so if the enemy is behind us, we're not actually going to do any kind of attack. Okay, so if the enemy is behind us, he sneaks up, and we're only going to attack him if we're beside him or he's in front. So if we're beside him, we're going to do a bit of an awkward kind of weak attack. Okay, so what we're going to do is we're going to take the move enemy script, and we are going to call the take damage function. And I can't call that right now because that's not public yet. So we'll go back in here, and I need to make this function public so we can call it. If we go back into the dot product, we'll be able to call this now. And we need to pass in a value into this. Okay, so we're going to pass in 10. Okay, we're just going to do a weak attack if the enemy is beside us, and if he is in front of us, we're going to do a strong attack. We're going to do 80 because the enemy is in this, you know, he's in front of us, he doesn't know that we're there. We're going to do a critical attack. Okay, now if I was to run this, this is going to happen a lot of times because we're not checking for an input. We want to check this for only if we press a certain button. So let's just check if we press spacebar. So let's check if get key down. Let me do key code dot space. So if we press spacebar, let's move that in there. That's when we do our attack. Okay, put that in there. I'm gonna do the exact same here. If input dot get key down, key code dot space. But then we'll do a critical attack and we'll do 80 damage. Okay, and again, we don't really need this one here. There's nothing going to go in there. So let's run this and see what this is like. Okay, so we go up. We're behind, the enemy's in front of us. He doesn't know we're here. We're in range, and we get a null pointer exception. Why is that? Because we haven't assigned the health, I would say. Yeah, we haven't assigned the health. So if we go onto the enemy, select the enemy script, haven't actually assigned the health here. So we'll just grab the text, which holds our health, pass that in there. Let's clear this and run it. And now if we go up and we're in range of the enemy, when we press spacebar, it does a critical attack. And if we go up beside the enemy here, so we can see the dot product is 0, meaning we're beside him, and we press space, it just does a weak attack of 10. Okay, and then again, if we turn around, the enemy will still keep going towards us. So if you don't want to be printing out the range, and we kind of want to know visually if we're in range, we can just add a sphere to the enemy. So let's just select the enemy, right click, add a sphere. And because we have the range set to 2, let's set this to 4. Okay, let's set this to 4 because that means we have 2 in every. The radius is going to be give us 2 units in every direction from the center. So let's just create a transparent material, and let's just call this see through. Let's set that to transparent. I don't make it whatever color you want, kind of yellowy, and let's just make this really transparent. And let's just drag that onto the sphere. Okay, so now we know that we're in range only when we're pretty much in this circle. Okay, so if we run this again, if I was to stand here and press space, nothing is happening. But if we go inside there and we press space, you see that we're doing a damage. Okay, and it's interpreting me as being directly behind the player still. Dot product of 1, that's why it did 80 damage. So that's pretty much it. That's this tutorial. The next one is going to cover doing a cone of vision for the enemy. So that should be out in the next day or 2.